Okay, so welcome to this uh, live session on 14/8/2026. Okay, so basically, we are in week 9. Okay, so week 9 is all about controller design. Okay, so using the frequency response. Okay, or compensator design using the frequency response. So specifically frequency response in this sense, we use here the Bode plot. So where previous week, so there's the same topic, compensator design, with root locus uh, we have discussed. Okay, so last live, okay, so previous live, okay, so I have discussed about in Bode plot the major things, so gain margin and phase margin. Okay, so let me repeat once again what exactly this. Okay, so we'll get some idea. Okay, so yeah. Okay, so the gain margin and phase margin. Let me explain you once again. Okay, so the curve may looks little confusing, but uh, I'll try to make it simple. Okay. Mm, yeah. Okay, so you can see here. So at the moment, consider only this left Bode plot. Okay, where Bode plot we have the. I think you can follow this. Okay, so Bode plot you have. Okay, so Bode plot you have magnitude plot as well as the phase plot. Okay, so is my voice is audible? My voice audible? Hello.
Yes, sir.
Yes, yes. Okay, fine. So you have magnitude plot as well as the phase plot. Okay. So in the magnitude plot, so the left part, what we will be discussing is phase crossover frequency as well as the gain margin. So you have magnitude plot and you have phase plot. Okay. Phase first, what you do is, so you have this phase plot. In the phase plot, identify this minus 180 minus 180 degree and draw this horizontal line and find this point. Okay. So if you extend that one to the down, you'll find some frequency that is nothing but omega PC, which is nothing but the phase crossover frequency. That is how you will find phase crossover frequency. Then the same thing if you extend up to the magnitude plot, check where you are hitting that plot. Okay. Then then draw this horizontal line. So here you got minus 10 dB. Okay. So then draw this another horizontal line at 0 dB. Okay. So that means that this horizontal line from 0 dB to 10 dB, you have a difference of 10 dB. Okay. That is called as the gain margin. That is called as the gain margin. So gain margin is how much the magnitude plot is deviated from the 0 dB line. Okay. Suppose if your plot is something like this. Okay. Now you can see that new plot is above the 0 dB line, above minus 10 dB. Okay. The old plot is below 10 dB. Okay, so always the difference is 10 dB. So we call that is as the gain margin. Okay, this is the definition. Okay, this is the uh, definition of phase crossover frequency. Okay, so phase crossover frequency and gain margin. Okay, using the magnitude plot as well as the phase plot. Similarly, in the same way, So here in the right side, we will define what is gain crossover frequency and phase margin. Gain crossover frequency and phase margin. So in the gain crossover frequency, how do you find? So you draw a line with the 0 dB line. Okay. And find what is that frequency. That will be your gain crossover frequency, omega GC. Okay. Then extend the same thing to the down. Extend the same thing to the down. Check where it is hitting this phase plot. Okay. Hitting this phase plot. So this is your horizontal line. That this is where it is hitting the phase plot. Then again draw a horizontal line at minus 180. And then find this difference. Okay, that will be your phase margin. So it is like from minus 180 degree line, your phase plot, okay, how much it is deviated. Deviated up or deviated down. Okay, that is called as the phase margin. Hope these definitions are clear. Very simplistic definitions. Okay, so is there any doubt in this? Okay, then we will now we will solve one or two problems. Okay, on the using these calculations. Okay, so finding this gain margin and phase margin. So you'll understand in a better way. Okay, so let's consider this example. Okay, so let us say we have a unity feedback system. Unity feedback means we take h of s is equal to 1. Okay, so unity feedback. Its transfer function is 1, and the plant transfer function is like this. Let's say 25k. So divide by s multiplied s plus 1, s squared plus 2s plus 25. Okay. So the plant is g of s, the feedback is h of s. So then first question is, so draw the Bode plot. So draw the sketch of the Bode plot for k is equal to 1. Okay. Then second question is, okay, so uh, find out on the Bode plot, find out the k for which we will get the phase margin as 45 degree. What is the phase margin we said? So your phase, the phase angle, okay. So how much it is deviated from 180 degrees? If the deviation is 45 degrees, for what value of k? That is the question. Okay. Also find gain margin for this k. Okay, find k value which will give us phase margin of 45. For the same gain k, find the gain margin. Okay, C. Okay, so find out the velocity error constant. Velocity error constant kV. Okay, so of the closed loop system for this k, for the k in B. The question k in B. Okay, so hope this question clear. So what we are trying to do here is, okay, so for h of s is given, feedback, plant is given. Okay, so we need to draw the Bode plot. Okay, after that, so for this phase margin, what value of k that will give phase margin of 45. Then the first for the same k, find the gain margin. Okay, then find out the velocity error constant kV for this k. Okay, so let us go one by one. If you have any doubts, you can ask me. Okay. Yeah. So solution. So let us start with given transfer function. So 25 by, so s into s plus 1, s squared plus 2s plus 25. So s plus 1, s squared plus 2s plus 25. Okay. So this is for k is equal to 1. Okay. So this I can write it like, okay. So if you take 25 common, okay. So I can write it like 1 by s multiplied s by 1 plus 1. You are taking 25 common. So s by 5 whole square plus 2 by 25 s plus 1. Okay, hope this is clear. So you take 25 common in both the things. Okay, are there any doubts? Okay, now I'll draw the rough sketch of the Bode plot. So it is just the rough sketch only for k is equal to 1. Okay, so what is it? 20 log mod z of c omega. Okay, mod z of z omega. So what we can do, how to draw the rough sketch, because there are no zeros here. Okay, there are no zeros, and here DC value, if you see, that is just 1. Okay, so let us start here at some point. Okay, let's say at the point 1. Okay, so the curve, approximate curve would be like this with this 0, this pole. So we'll get a minus 20 dB per decade. Am I correct? Okay, so let me draw it again. Okay, something like this, first part. Okay, second, this is again a another pole. Okay, so that pole also will create another minus 20 dB per decade. Okay, then we have 2 poles here. Okay, because it is S square. So there it will be like this generates, sorry, here this will be like minus 40, because minus 20 minus 20 plus 40. So here this will be generating like how much? 2 poles. So it will be like minus 60 dB per decade. Okay, you can see this. Okay, so you can start doing the calculations. So this will be at corner frequency 1. This will be at corner frequency 5. So hope this is clear. Okay, so now you can find these points 1 comma, let's say y1. Okay, this will be like 5 comma y2, etc. Okay, so this what you get, you'll get 1. Okay, am I correct? You get that is as 1. Okay, so any queries here? Any queries?
No, sir.
Yeah. So now what to here your job is to find y1 and y2. Okay, how can you find y1 and y2 here? So y1 will be like let me write it straight away, you will understand that. So how do you find y1? So that is equal to slope. What is slope? Minus 20. What is the value? 1 minus y1, y2 minus y1 divided by x2 minus y1, because the scale is logarithmic scale, x-axis. So log x2 is 1, x1 is 0.1. Okay, so 0.1 by 1. Okay, so this is the equation. What do you get? You'll get y1 here. That is like let's say if you do the calculations, you'll get minus 20, minus 21. Similarly, you do the same calculations for y2. So y2 will be like minus 40. Okay, then minus 21 minus y2 divided by log 1 by 5. Just finding the slope. Okay, so what do you get? This will be y2 is equivalent to what? Minus 48.9. Okay, so these are the two values we are getting. Y1 is minus 21, y2 is minus 48. So it means what? So minus 21, minus 48, it means that your curve has to go down. Your curve has to go down. Okay, so let me copy this. Let me copy this. I'm getting okay. So let me copy this. Okay. I'll paste it here. Okay, now you can see. So we'll write down the updated this thing. So the curve has to go down. So this will be minus 1. Okay. So it has to start here and go down. Go like this and go like this. Okay. So this value will be like minus 21. Okay. whereas this value is like minus 48.9. Okay, is this clear? So these are our points. This is our Bode plot. The red curve is our Bode plot. Is there any doubt in this? That is our
No,
first question. If you have any queries, you can ask me. Okay. So this is our first question, question A. Okay. So given the transfer function, okay, find the Bode plot for k is equal to 1. Okay. So here I wrote it directly because I don't have any zeros here. So all we have only poles only. Okay. So now second question. Okay. Second question is you need to find the value of k for which the phase margin is 45 degrees. And also for that k, you have to find the gain margin. Okay. So what do we have? We have g of s. G of s is this function. Okay. So g of s is this function 1 by, so 1 by s multiplied s by 1 plus 1. So s by 5. Okay, whole square plus 2 by 25s plus 1. Okay, correct. So now, find out z of j omega. Okay, so that will be like 1 by j omega plus 1. Okay, so it will be minus omega squared by 25 plus 2 omega by 25j plus 1. Correct? Okay. So that is our equation. So how do you write this one? So separating the z terms and real terms, j omega plus 1. So here what is it? 1 minus omega squared by 25 plus, so 2 omega by 25 j. Okay. So this is the one. Okay. So directly now we can calculate because we are interested in the phase margin. Okay. So let us find out the phase. What is the phase? G of j omega, an angle. Okay. So here you can see one by one. So the first, this 0 introduces minus 90. Minus. What is the angle of this? Tan inverse omega. Okay. Minus. What is the angle of the other thing? This part? Tan inverse. Okay. So imaginary part by real part. So that will be like 2 omega by, how much you'll get? 2 omega by, so 25 minus omega square. The 25 will get cancelled. Am I correct? 25 will get cancelled. Correct? Any doubt in this? Any doubt in this? Any doubt?
no, sir.
Yeah. So if you have any doubts, you can ask me directly. Okay. So now as I explained, so in the previous thing, okay. So, okay, so, I'm sorry. Basically, what is the mm, what is our phase margin? So phase margin and gain margin, we have these definitions. Okay. So you can plot this thing first. Okay. So since you have this equation, okay. So using this equation, okay. So you can plot it. You can because the just a minute. So we can copy this. Let me copy this. Okay. So right. So now plot the Bode phase plot of the Bode plot. So that is angle z of j omega. Okay. So again here is we have omega. Okay. So let us say approximate plot. Okay, we said that we are interested to find the K value, okay, for which the phase margin is 45 degrees. Okay, basically what is phase margin? Okay, the phase plot, how much it is deviated from minus 180. Here, what is the deviation? That is 45 degrees. Okay, so that means what? Okay, so if you consider, if you take up this minus 180 degree line, okay, if you take up this minus 180 degree line, okay, from here, there is a deviation of, so there is a deviation of 45 degrees. So this much deviation. Okay, so that means what? Deviated means that will be minus 135. Correct? That is 45. Okay, so the deviation, I write it like this. Okay, this is minus 25. So now this is the point. Okay, so the curve will go from this point. Okay, the curve will go from this point. So you can write it like this. Okay, you can write it like this. Okay, where you'll have the points like here, 1 point. So the corner frequencies are 1. Here another corner frequency would be like 5. Okay, so then 10, then 100, etc. Okay, so what is this? This is 45 degrees. This is 45 degrees. Hope this is clear. Any doubts? If you get any doubts, you can ask me.
So, okay, sir, no doubt.
Yeah. So what basically you do is this is the phase plot. Okay. Let me reduce this. So what basically you do is, so we find the phase plot and magnitude plot. We'll have both. Okay. What is our magnitude plot here? So the magnitude plot is like this. So the magnitude plot is this one, where it starts at -1, so goes down like this. Okay. So if you take up that, okay. So if you take up that, okay, so it starts at -1. Then we have -21, -48.9. So -21, -48.9. Okay. So we have this curve. So how do we have curve? Yeah, so three slopes. So three slopes we have. These are the three slopes. Okay. So one at 1, another at 5. Okay. These are the things. Okay. So basically, this says, okay, so this point. Okay. So this is your omega GC. Whenever that is equivalent to 45, this is your omega GC. Okay. So that will be, you will get that is as 0.854 radians per second. Okay. So that is your omega GC. So it is like mod gain margin. Okay. So omega is equal to omega PC, that will be equal to 1. Okay. Whenever you have this value. Okay. That is how you'll find the this K value. Okay. So you equate your phase margin to 45 degrees and find the K value. Okay. So use that K and find this omega PC to find the gain margin. Okay. So that is the second question and third question. Okay. So third question, you can find it directly. Okay. So velocity error, KV. So to find the steady state error. Okay. So I'm giving this as a homework problem. You can give a try on this KV. Okay. So only thing is that in the second question, first you equate that one. Okay. So what you do in general, so first if 45 degrees is given to you, okay. So 45 degrees, find that omega GC function. Okay. So with the 45 degree, find this omega GC. So if you draw it in MATLAB, okay. So you'll get omega GC as 0.84 radians per second. Okay. Once you have 0.84 radians per second, so that is where uh, that is where your the phase margin is deviated by 45 degrees. Okay. So that means what? So at this frequency, okay, you can equate minus 180 plus 45, that is equivalent to angle G of j omega GC. It means, so substitute this 0.84 into this equation. Minus 90 minus tan inverse 0.854 minus tan inverse. So 2 omega 0.854 divided by 25 minus uh, uh, divided by 24. I'm sorry. Just a minute. So this has to be omega. So you can find it without even going to the MATLAB also. So equate that one to omega GC minus tan inverse. So 2 omega GC by 25 minus omega GC square. Okay. So if you solve this equation, you'll get omega GC as 0.854 radians per second. So that's how you'll find it. Okay. Omega GC. Okay. So omega GC, you'll find it from the this phase matching. Okay. So then you can find the K value. Okay. Once you have the K value, you can find the gain margin. Gain margin is nothing but using this equation. So take the magnitude. Okay. So magnitude is nothing but 25K. Okay. Divided by so omega. So magnitude of the function. So root over omega square plus 1. Okay. So root over 4 omega square plus omega square minus 25 square. Okay. So make it equal to 1. Okay. Substitute to omega is equal to 0.854. Okay. So that is how you will find the gain margin. Okay. So here, so gain margin, gain crossover frequency. Okay. So that is the solution. Okay. So are there any specific queries? Are there any specific queries? Yeah. So stick to the definitions of gain margin and phase margin. Okay. Next problem, or you can also ask me. So next, I wanted to take one design problem. Okay. So otherwise, we can ask me any questions on the quiz 2 syllabus. Consider if you have any queries.
So one thing I want to ask.
Yeah.
So as far as I know, we also have to do some design assignment, right?
Design assignment, yes.
So from when the design assignment should be starting?
Design assignment will release by Sunday.
This Sunday, right?
Yes. So they will
Sir,
be
will there
based
be
on
any,
yes.
will there be any revision session for quiz 2, or we have to prepare only?
There is no specific revision session until unless students ask for the session.
So
Because
should we schedule one revision session tomorrow, sir?
tomorrow, I'm not sure, I'm not available. But
So
I'll check with madam also. If she is
yeah,
available, we can discuss. I'm not quite sure. So Sunday, when you have exam, at what time?
eh, it's from 1 to uh, starting from in afternoon session, sir. It's
Okay.
starting
Then
from
Sunday is not possible. Not possible.
no, Sunday is not possible, sir.
Okay.
So we can at least one revision session tomorrow if it's possible.
Tomorrow I'll check with another instructor because I'm not available.
Okay,
Okay,
Krish.
but what you can do is you can ask me the doubts.
I am made to revise. I have three subjects. I'll revise control tomorrow. So
Okay,
I don't
okay,
if
okay.
there will be a,
Yeah, then it's fine. It's fine. I'll ask madam and we'll try to set up one
and sir, one more thing.
doubt clearing session.
Will there be design question in quiz two? Like week 8 is totally
No, no,
based
no,
on,
no, no, no design
so
questions.
so as far as I think, I don't think there will be any question at least from week 8. Is it?
Uh, yes, exactly.
So mainly,
Week 8 and week 9. Okay. So they are completely design problems. So you'll not get any questions.
so from week 5 that RH criteria, from week 6 that root locus, and from week 7 it's
Yes, yes,
Nyquist as far as I remember.
yes, yes, exactly.
Okay, sir. So
So you have RH criteria, root locus, Bode plot, Nyquist plot. Okay, these are major things.
okay, sir.
The frequency
I
response.
I'll revise control tomorrow. So if by in night also, if there is if you are free in
If
night,
we are no, no,
eh,
we cannot take many live sessions, extra live sessions. Okay. But if you have any questions, you can post it in this course. We'll answer immediately in view of this exam. Okay. So, but
oh,
tomorrow we'll try to set up a call. Not sure yet, but you can post your questions. We'll try to answer immediately. Okay. You
okay,
can also mail us.
okay, sure, sure.
You can also mail us. So we'll give the response quickly. Okay.
Okay, sir.
So
Thank you.
I'll quickly discuss one design problem also, particularly in the lead compensator. Okay. So for the lead compensator using Bode plot. Okay. So we have the closed loop control system. So we have D of S. So this is the compensator or controller. Okay. Then we have G of S. Okay. The output is C of S. So we have unity feedback system. Okay. So then we have reference signal R of S. Okay. Suppose if G of S is, okay, so 25 by S into S plus 1. So S plus 5. Okay. So the question is like this. So draw the Bode plot first. Okay. Draw the Bode plot and design. Okay. So it's D of S, which is the lead compensator. Lead compensator D of S. Okay. So that the phase margin is greater than 40 degrees. Lead compensator such that the phase margin is greater than 40 degrees. Okay. So consider the gain of D of S. Gain of D of S. So at omega is equal to 0 is 1. Okay. So that is the assumption. Okay. So also find the bandwidth. Also find the bandwidth. So here the main point is how to design this compensator, which will give us this phase margin of 40 degrees. Okay. So I'll give this first Bode plot directly. So what do we do? I'll give the calculations directly. Okay. So what is my Z of j omega would be like? Z of j omega is, if you take up the 5 common, you'll get it like, so you'll get it like j omega. So j omega plus 1. Okay. 1 plus, you'll get 0.2 j omega. Okay. Because we wanted to write it like, so something like this. Z of S equal to take 5 common. Okay. So you'll get it like 5 by S multiplied. So 1 plus S multiplied 1. 1 plus S multiplied 1 by 5. Okay. So that is written like this after substituting S is equal to 0 omega. we have this equation. Okay, so now we have three poles. Okay, so what are the poles we have? So 1, 2, 3. Okay, so what are the poles? Pi by j omega. Okay, so 1 by 1 plus j omega. So 1 by 1 plus 0.2 j omega. Okay, here the slope change here. So the corner frequencies are like, will not have any corner frequency. Here omega c1 will be 1 by 1, that is 1. Here omega c2 is 1 by 0.2, that is 5. Okay, these are the corner frequencies. Then the slope changes here minus 20, minus 20, minus 20. Each one introduces minus 20 slope. Here first one there is no change. The next one here is, so minus 20 plus minus 20 equal to minus 40. Then minus 40 plus minus 20 equal to minus 60. Okay, that is the slope change. Okay, so now what is our next step? So next step is to draw the Bode plot directly. Okay, so let me draw that. So what you do is you have three corner frequencies. Okay, so let me take up here. Okay, so take omega L is less than omega C1. Okay, so what is omega C1? Omega C1 is 1. So then take omega L is equal to 0.1. Okay, so at omega L, find out A. Okay, so 20 log mod z of j omega L. Okay, so if you do this calculation, that is like 20 log mod, so 5 by 0.1 root over 1 plus 0.1 square, root over 1 plus 0.2 multiplied 0.1 square. Okay, mod. So this is like about 33.93 dB. Okay, similarly at omega is equal to omega c1, 1. Okay, so what is the value here? If you do the same calculation, okay, so you will get 13.93. So this is first part. Okay, this is first part. Second part is, so omega is equal to omega c2, that is 5. Okay, so there you will do the calculation. A is equal to what? The slope change at omega c1 plus omega c2 multiplied log omega c2 by omega c1. Okay, plus A at omega is equal to omega c1. So that is nothing but minus 40 multiplied log 5 by 1 plus 13.93. So that is like minus 14.02. Okay. Then what you do, you will choose omega h, which is greater than omega c2. Okay. So omega c2 is already 5. So omega h you'll choose, let us say 2 times that omega c2, that is 10. Okay. Here also you do the calculation CA. Okay. So slope change at omega c2 to omega h plus, okay, so sorry, so this is multiplied by log omega h by omega c2 plus A value at omega is equal to omega c2. That is nothing but minus 60 slope multiplied log 10 by 5. This is standard procedure, plus the value is minus 14.02. So you'll get minus 32.08. Okay, this is the magnitude. Ultimately, so omega CL, this is the value. Omega C1, 13.93. Omega C2, 14.82. Omega H, minus 13.32.8. Okay, these are the values. Okay, so you can draw the plot. So let me draw here. So you can draw the plot here. Okay, what are the corner frequencies? This is 0.1, 1, 5, 10. Okay. So at first, what is the value? So that is the at point one, the value is the 33.93. 33.93. So at one, what is the value? 13.93. This one. Okay. At two, what is the value? Minus 14.02. At 10, what is the value? Minus 32.08. So this is minus 14.02. This is minus 32.98. Okay. So now you can plot them. Okay. So from here, the value goes like this. Okay. Then from here, that goes in the negative way. Okay. It goes like this. Then here, so the value is at this one. Okay, so that's the value. That's the Bode plot. Okay, so this is okay. So mod z of j omega dB. Okay, what are the slopes? This is minus 20 dB per decade, minus 40 dB per decade, minus 60 dB per decade. Okay, what are the points you'll have? So you'll have this one is 1 comma 13.93, and this one is the 5 comma minus 14.02. Okay, so this one is 10 comma minus 32.98. Okay, so you can see here the plot is touching this 0 dB line here. So what we can say that is nothing but omega GC comma 0. Okay, so 0 dB line. Okay, so that is the gain crossover frequency. Okay, the gain crossover frequency. So what do we do? So this is making 0. It means that mod z of j omega. Okay, so at gain crossover frequency, the value will be 1. If you substitute it, that means, so whatever the magnitude you have, okay, whatever the magnitude you have, okay, so that is 5 by, so omega root over 1 plus omega square, okay, root over 1 plus 0.2 omega whole square, okay, equal to 1. Okay, so if you do that, or you can find the slope also. Okay, so you can, even if you try in the slope also. What is the slope here? Basically, minus 40 equal to here the slope between these 2 points. So this point and this point. What is that value is 0 minus 13.93 divided by log omega GC divided by 1. Okay, so if you do these calculations, so you will get omega G as 2.29 radian per second. Okay, so this is the value where your magnitude is becoming 0. Okay, is this clear? Any doubt? That you are finding just by taking the slope of this point. Slope is minus 40. This side point is omega GC 0. This side point is 13.93. So you are just applying the slope equation. Then you are finding that omega Z. Okay, so that is gain crossover frequency. Phase crossover frequency, how do you find? So take the phased angle. Okay, so what is the phase angle? Phi. That is nothing but angle Z of j omega. That is nothing but, what do we have there? So we have G of S as, okay, we have G of S as, so S plus 1, S plus 5. Okay, so that is like S, it will give you 90, S plus 1, it will give you tan inverse omega, and the S plus 5, because we are taking 5 common there. So it will be 1 by 5. So, so the phase crossover frequency is nothing but whenever your phase is equal to the minus 180. Okay. So you can substitute everything. So the minus 90 goes that side. Okay. You will get minus tan inverse omega minus tan inverse 0.2 omega equal to minus 70. Okay. So that will be like tan inverse omega plus tan inverse 0.2 omega equal to 90. Okay. You can take tan on both the sides. Okay. You can take tan on both sides. Okay. So then you can apply it. Okay. And solve for omega, which is nothing but omega PC. Okay. You will get it like 2.29 radian per second. If you solve for omega, I'm not showing all that calculation, but you will get it as 2.29 radian per second. That is the uh, crossover frequency. Okay. Hope this is clear. Okay. So that you can get it from the phase plot also. Okay. So if you plot the phase plot, you'll get the same equation. Okay. So now, so you can calculate it. Okay. So the gain margin. So how do you find the gain margin? So the gain margin is the 1 by, okay, so 20 log mod V of j omega at omega PC. Okay, so if you substitute and get the calculations, you'll get the value of 1.58 dB. 1.58 dB. That is gain margin. Okay, so now, so what is our question? The question is, so plot the border plot, design the compensator now. Okay, and make the phase margin greater than or greater than 40. That is our question. Okay, so what we can do is first find it out. Okay, first just a minute. First find the phase margin. Okay, so first plot, you have the magnitude plot and plot the phase plot also using both and using MATLAB. Okay, so first plot phase, sorry, magnitude as well as the phase without compensator. Without compensator. Okay, so find out the phase margin. Okay, find out the gain margin as well as the phase margin. Okay, so you will get gain margin as so the 1.58 here. Okay, you'll get phase margin as uh, uh, 1.58, gain margin as sorry, phase margin as 3.94 3.94 degrees. Okay, so here the gain margin, you will do the calculations for phase crossover frequency. What is the phase crossover frequency? So 2.29. Okay, and phase margin, you will do the calculations for gain crossover frequency. What is the gain crossover frequency? 2.04 radians per second. Okay, so you'll get these two values. Once you have these two values, okay, now what is your job? Your job is to make phase margin greater than 40. That means what? The uncompensated system is giving a phase margin of 3.94. Okay, so now using compensator, you have to increase your phase margin to minimum 40. Okay, so using compensator. Using compensator. So what is that compensator? Using lead compensator. Okay. So lead compensator, the basic equation goes like this. D of S equal to Kc alpha 1 plus tau S divided by 1 plus alpha tau S. Okay. Here in the question already given that the D of S, okay, so that is equal to 1 when omega is equal to 0. That means what? So Kc alpha equal to 1. Because once you substitute S is equal to 0 omega, substitute omega is equal to 0. So you'll get this. Okay. So the required phase margin is the phase margin what we have is how much? 3.94. Okay. Now the required phase margin is 40 degrees minimum. Okay. Required phase margin is 40 degrees minimum. Okay. So we need at least, okay, so at least the 36 degrees. Okay. So the additional what we need is, so additional we need at least 36 degree. Okay. So now find the pi m corresponding to this. Okay. So pi m is nothing but that 180 degree. From 180, how much it is needed? Okay. So that will be like 60 we require. Okay. So now we have this formula sin pi m. Okay. So of course this formula is the same as when we see the root locus also. Okay. So from this you will find alpha. So 1 minus sin pi m divided by 1 plus sin pi m. Okay. So 1 minus sin 60 divided by 1 plus sin 60 equal to 0.0718. Okay. So now we have this Kc alpha equal to 1. So this means Kc equal to 1 by alpha. Okay. So that is 1 by 0.0718, which is equivalent to 13.92. Okay. So that is, we have calculated alpha. Now what is this tau? Okay. So the tau you can calculate like this. So the tau here is nothing but the attenuation. Okay. So the required attenuation is, the required attenuation formula is 20 log, so 1 by root alpha. Okay. So if you substitute it, 20 log 1 by root 0.0718, which is nothing but 11.44 dB. Okay. So for this, the new gain crossover frequency. The new gain crossover frequency is, so we should get is omega is equal to 4.3 radian per second. Okay. Once you have this omega, you can calculate it. Oh. So omega root alpha, which is nothing but 1 by root. Okay. 4.3 root alpha is 0.0718. Okay. So 0.8679. Okay. So the total compensator finally is, so D of S equal to, so 1 plus 0.8679 S divided by 1 plus 0.0623 S. Okay. So finally your compensated system is G of S D of S, which is nothing but, okay, so which is the 25 by s multiplied s plus 1 s plus 5. Okay, so 1 plus 0.8679 s divided by 1 plus 0.0623 s. This is the system. Okay, in this system you'll get a phase margin of minimum 40 degrees. Okay, so if you can also plot it and check that. Okay, you can plot it and check it. You will see minimum 40 degrees. Okay, so these formulas are same as that of the then lead and lag. Okay, so I'll share these three problems. So one is with the first problem, second is lead, and third lag also. You can use these three while doing this MATLAB assignment. Okay, so are there any queries?
No, sir.
Yeah, so you can go through the examples and you can ask me. So I will post it on this course if there are about the
Sir,
live
I have a
session. Okay.
question.
Yes, yes,
Sir, the
yes.
question
Tell me.
is
Uh,
uh, the open loop transfer function of a unity feedback system is given by GS is
Open
equal
loop
to
transfer function.
AS.
What is your question?
The open loop transfer function of a unity feedback system is given by GS is equal to AS plus 1 upon S square.
GS is equal to AS.
AS plus 1 upon S square.
Okay.
And the value of A is such that the phase margin is 45 degree.
The value of
A such
J.
that
Okay.
such that the phase margin is 45 degree.
Yeah. Okay.
Yes, sir. This is the question.
This is the question. Okay. Fine. Fine. So first, what you need to do is okay. So see, basically, try to understand these definitions of phase margin and gain margin. Okay. So the phase margin and gain margin basically, so gain margin and phase crossover frequency are together. Okay. Then phase margin and gain crossover frequencies are together. Okay.
Yes, sir.
Okay. So when you get this gain margin, gain crossover frequency, okay, so let me explain you again. Okay, so generally what we do, so the question is now related to this. Okay, so first you need to get gain crossover frequency. Okay, first what is that gain crossover frequency? Because you will get phase, you will calculate the phase margin using gain crossover frequency. What I mean to say is you have the magnitude plot. Okay, Z. Okay, you have phase. Okay, so you will find the phase margin in the phase plot. Okay, so to that you require this gain crossover frequency. Is that clear?
Yes, sir.
The gain crossover frequency is nothing but whenever your the phase this will go to 0, the magnitude plot. Okay, you got
Okay.
my point?
Yes, sir.
So that means that mod z of j omega equal to 1, because log 0 is 1. Is that clear?
Yes, sir.
So this is the frequency where this will be equal to 1. That is nothing but the omega, that will be omega gc. Is that clear?
Sir.
Now,
Yes, sir.
is that clear point? So
Yes, sir.
now
Yes.
you start with this. You start with this, find omega gc. Okay.
Okay.
Okay. Then once you have this omega gc, Okay, this omega GC, you will extend this line. Extend this line. Okay, you got it?
Yes,
Now,
yes,
what
yes,
is
sir.
basically phase margin? Phase margin is something that when you have this minus 180 line, okay, so minus 180 line, okay, your phase plot, how much it is deviated? Here it is deviated by how much? 45 degrees.
45 degree.
Okay, it will be something like this. Okay, this height is 45. You got it?
Yes, sir.
That height is 45 means what? This one. What is that will be? Minus 135. Am I correct?
Yes, sir.
Okay, this one. Okay, that phase is what? Minus 135. You got it now?
Yes, sir. Yes, sir.
Now, do it like this. You got it?
Yes, sir.
What is this angle? This angle has this A, right?
Yes, sir.
You know already the omega GC. That is equivalent to minus 135.
Yes,
You'll
sir.
get the A value. Clear?
Okay.
Yeah, that is how you'll do the calculations.
Okay, sir. Okay, sir. Thank
Yeah.
you.
So that's why I said gain margin and omega phase crossover frequency, phase margin and gain crossover frequency. You will find gain margin using phase crossover frequency. You will find phase margin using gain crossover frequency.
Okay, sir.
Okay?
Got it.
Yeah. So I'm not sure about tomorrow's live, but if it is, if we can do that, even be ready for around 8 to 9 p.m. also.
Okay,
Okay,
sir.
we'll send you the
That also
message.
will be. Okay.
Yeah. Even so, please be ready even for 8 to 9 p.m. also.
Okay, okay, sir.
Okay, yeah.
But
But
make sure
what you
that it
can do
doesn't
is,
collide with any other live session.
no, what you can do is, so without waiting for the live session to happen, so and also remember that even if live session is happening, we will not revise the concepts. Okay.
Okay.
Because all concepts are explained clearly in the videos. What we do is we will clear your doubts.
Okay,
Whatever
sir.
the doubts you have, you will clear only those doubts.
Okay, sir.
Because all concepts are available in the videos and we have already explained in live sessions. Those live sessions are available. Okay. So explain those concepts again is the waste of time because control system all about solving the problems.
Okay,
Okay.
sir.
You come up with the problems, then we will try to solve them. That will
Okay, sir.
be
Sure, sure.
thing. So, but you post your questions directly on Discord. Better we'll get the answers immediately. Okay.
Okay,
So
sir.
I'll let you know about this session by morning. Okay.
Fine.
Yeah.
So do
Okay.
we have
Thank
any
you.
surprise test today or not?
Surprise test, no, not in the design assignments. Okay. But for the next 10 and 11 modules, we'll conduct the surprise test.
Okay, sir. Thank you, sir.
Okay. Yeah. Okay.